Chapter 15, sample problem number 14. Two equal-sized cubes that have different masses are held by strings so that they are submerged in water at different depths. And we want to know for each of the following, is the buoyant force on the 3 more than on the 1? Is the tension in the string holding up the 3 more than on the 1? Or is the pressure on the bottom of the 3 more than on the 1? So tackling A first, well actually let's say tackling what we know that they are equal sized, and that's going to be important, but they have different masses, and that's going to be important. So our first thing is to say, well, the buoyant force is always the mass of the displaced water times G, which is the density of water times the volume of the object times G. But since they are identical objects, equal size cubes, they have equal volumes. The water, of course, is the same, and G is the same for all of them. So we end up with that these forces are equal. The buoyant forces are equal. But if we then say for part B, for each of them, there is going to be a weight pulling it down, which is mg, and there's going to be the buoyant force pushing up, and there's going to be a tension also holding it up. And we see that those Ft plus Fb minus mg has to be 0 because they are the net force, and the acceleration is 0. So then the tension is the weight minus the buoyant force. And so since they both have the same buoyant force, the tension is going to go with the weight. Since the 3 kilogram block is being pulled down harder and is being supported the same, the string has to put in more effort. So this is going to say that the string has a greater tension for the heavier mass. And then finally, we're going to say that the pressure in a liquid is based on, we'll say delta pressure, is based on the density of liquid times G times the depth below the top. And so we can see that the deeper you are, the greater the change in pressure. They, of course, share the pressure at whatever the 1 atmosphere is that up here. So we see the deeper thing has the greater pressure, which means that the pressure on the 3 kilogram cube must be less than the pressure on the 1 kilogram cube.